Hello everyone and welcome to episode 14 of Nelson's Corner. In this video we will be continuing on with the creation of the card game engine that we've been working on for the last few videos. This is going to be part 5, I do believe. Now Nelson has promised to us that this will be a boring video as he's starting to get some of the infrastructure set up. Now joining us tonight we do have Mr. Zach Parrish.
Hey, how's it going?
Of course, Nelson himself.
Hey.
Hey. And special guest star, Gavin. Hey Gavin.
Hey!
Hey, it's good to have you here, man. Gavin has a very special job tonight, and if he does a real good job of this, we're going to have to bring him along a little more often when Nelson's teaching these videos. What Gavin's going to do is make sure that Nelson just doesn't speed up so fast that, well, you know, everything gets coded in between frames.
That's true.
So that... Oh. Go ahead, Gavin.
So I'm essentially to blame. I am Minister of Peace, am I?
I like it.
Something like that.
That's right. That sounds very good.
I'm the one that gets blamed when it's too fast.
Well, I wasn't going to say that, but now that you've inked it in, and it's very clearly stated in front of everyone, yes. So everyone knows who to fuss at on 3D Buzz.
Oh,
it's not us.
But Gavin's also going to do a great job, as he does watch these videos, of throwing in questions if he's confused about anything. And so that means, Nelson, if you want to ask questions, just poke Gavin and see if Gavin's awake and paying attention. It should be loads of fun. So with that, let's go ahead and hand it over to Nelson, and we'll get this project actually started.
Yeah, so in this video, I guess we're just creating the projects, some of the interfaces, and I guess some of the value types that go along with those interfaces. Sound good?
Mm-hmm. Sounds great. I mean, I know you're so worried about it's going to be boring, but I mean, we've got to start somewhere, especially since we do a good job of always recording everything when we build these different applications. It would not be wise for us just to start with 40 classes already made and some dependencies already established, and that'd be confusing.
Alrighty, so I'll go ahead and start with a solution called Card Game, and I'm going to add a few projects to it. And the first project we're going to deal with eventually at some point, but it's going to be cardgame.base, and that's lowercase. And this is what I hate about Visual Studio. When you delete a project, it doesn't actually delete it. So I have to go in, right-click, open a Windows Explorer, and that popped up here. And then go to cardgame.base and delete. The reason I deleted it was base was lowercase, which is unacceptable.
Now, Gavin, you are keeping up at the speed in which Nelson is talking, right?
Yep, that makes sense. I'm not actually coding along because I'm focused.
Okay.
This is my first time doing this, and I'm focused on
of course,
watching what the hell's going on.
Okay.
Okay. Now that we have a proper capitalization of base, I'm going to go ahead and create the cardgame.engine project, and then I'm going to create the console project. And we're going to be using the console project to do some initial testing on the loading up in the environment and all that stuff. And then I'm going to go ahead and set this as the startup project. And now we have our projects created.
Just to double check, the other two were regular projects with the base in the end.
Yeah, regular class libraries.
Cool. Class libraries, DLLs.
Yes.
Right.
Okay. So the first interface I'm going to create is I kind of want to actually show people what this is going to sort of look like before I start writing out the interfaces, if that makes sense. Mm-hmm. Just to give people context about how I'm going to be using these classes initially. But I'm going to create what's going to be called the game engine. That's the best name that I have for it. It's more like the game environment, which is going to be a new card game environment. Then we're going to go ahead and load up or load collection from JSON file, and we're going to go ahead and point it to a card collection that is defined in a JSON file, and we're going to go like data collection collection.json.
Okay, what is a JSON file?
Yeah, actually, that's important to know. JSON is JSON, or JavaScript Object Notation. Some people pronounce it in this really weird way that I can't get my mouth to work in, but it's like JSON or whatever. It's JSON. And what it is it's the JavaScript object notation. It's a syntax ripped directly out of JavaScript as a language that allows you to define data in a really succinct way. Think about it like sort of like XML, but a lot better. And basically any instance where you might want to use XML, with the exception of actual markup languages like XAML or HTML, or XHTML, sorry, you'll always want to use JSON for storing data. And it kind of looks like this. It's pretty freeform. You have these objects which are stored in these inside curly braces. That's a JSON object. Inside the object, you have key value pairs, which are associated with just the key on the left, and then a colon, and then the value. Values can be anything from strings to numbers and so on. Values can also be arrays. And arrays are defined with the square bracket syntax. So I can have an array of 3 strings. And so this just defines data. It's just a data serialization format.
Is it dependent on white space?
Nope.
Cool.
So
Hang on one second. Gavin, you're doing awesome.
Yeah.
I like it.
Sorry.
No, because you're a real...
Somebody says you're doing awesome. You do not reply with, I'm sorry.
I know. No, I just wanted to throw that out there real quick because you being a real student, that was awesome. Great question. But
okay.
I did want to ask Nelson something real quick, and he may sigh, maybe not, hopefully not. With the projects that you've set up, have you considered doing a unit test project as well?
Not probably. I mean, I could for the original engine. The reason I didn't in coding it, the engine has such a simple interface. Mm-hmm. However, there is going to be an instance once we start building up cards that is something that I haven't talked about with anybody yet, but I have it all planned out in my head, and it's going to be brilliant, where we have these...
Well, that's reassuring.
Where we have these unit tests that actually
play a few...
Yeah, plays the game and then actually validates the result. And that's how we're going to unit test the individual cards. We're going to say, okay, these 2 decks happen. This person draws 7 cards. That person draws 7 cards. Obviously, the decks are stacked in a particular way. This person plays a card. In response, this person plays a counter. Make sure that card's effects didn't happen.
Right. And so why don't we just go ahead and get a project set up? And I mean, because even though you're saying, oh, the engine's going to be simple, it's I don't know, very viable in my opinion, but that's just me.
Well, okay. I mean, we're going to have it eventually anyway, even if we don't use it for the initial environment stuff. So I can go ahead and create the class library for, what do we want to call this? Tests will be good because tests will sort last after engine. Mm-hmm. People who don't pay attention to the the order in which the characters of the alphabet are ordered in, kind of irritating.
That was worse. Sorry.
And I messed up.
Yeah, because you went with engine, and then you went with card game.
Okay, now we have to do this again. Windows Explorer.
People who don't pay attention to what they're naming projects.
Yes, as far as how they're going to be sorted in the Solution Explorer. That irritates me.
Nelson's a big stickler.
So he just irritated himself, basically.
Okay,
Yes.
so, well, I was talking... anyway, so let's go ahead and manage some NuGet and get some NuGet action going on. And unit... And wait for that to install. Fluent insertions, and I love NuGet. We should have some videos about NuGet. I'll talk about that later. It's awesome. Okay, so that's an example of JSON. So our game engine, I'm actually going to rename this. I don't know why I called it engine. We're going to call this environment. And the environment, as far as the
That's
APIs,
not correctly spelled. Environment?
Yeah, your O and your I. And on the other side, too.
Yeah,
you're
the
still...
environment.
Environment.
ENVIRON.
Anyway, so now that we have environment, let's go ahead and do some more stuff like load deck from JSON file. Deck 1. So I just want to give an idea about how this entire API is going to look, and then we're going to say game is going to be environment start game, And then I'm not sure about the signature of start game. I'm probably going to pass in some sort of configuration object that'll associate the decks to the particular players.
Right.
But that's pretty much the entire public-facing API for the most part of what we're going to be building. The code behind is going to be obviously a lot more complicated than this, but I just wanted to point out this is the end goal for what we're doing right now. We want to get cards loaded from collections into the environment. Then we want to get decks loaded that are using cards from these collections loaded into the environment, and then we want to use that information to start the game.
Okay.
Okay, so the first step, I guess, would be to create the actual iCard game or iCard environment. As we're going to go ahead and just create an interface for it.
Mm-hmm.
So and he's going to be pretty straightforward. All he's going to have is an IEnumerable of iCard collection called collections. And then he's also going to have an IEnumerable of iCard definitions. Then he's also going to have an IEnumerable of iDeck decks. And then finally, he's going to have a kind of a helper method, I guess you could say, an iCard definition method that says get card definition, GUID, brought in system, collection ID, GUID, card ID. Alrighty, so does that make sense to everyone?
Yep, it brings up a question that a sort of a wider question that I have which is when to use static and when not to use static.
As far as?
Is the special rules with abstract classes about using static for methods?
Not really as far as if you have a static class, you have to use static. In this particular instance, I actually don't use static things very often. Usually I only use static things for extension methods and perhaps some utility method that doesn't require an object instance. But I won't be using a lot of. Static things are usually an anti-pattern in that they allow code coupling in the environment.
And that means?
That means that any class can access these static classes without having to create them first, which means that that static context can be executed before code or before the environment can be properly set up. Which introduces things like you calling code before you should be able to. In addition to that, it also makes it impossible to sort of maintain a list of all active objects at the moment. In addition, it also makes it more difficult to change things down the road when you want to change the implementation of a particular method. Because if it's static, everybody has access to it all the time. So if everybody uses it and you change it, you're going to have to go through every single instance where you don't want it changed and update the caller site.
Right, okay. Yeah, that makes sense.
Alrighty, so we have a iCard definition. I'm going to go with that one next. I'm actually going to put him in another namespace called card definitions.abstract. And the iCard definition, we already kind of talked about it in the
basic theory stuff, the overview.
Right. The iCard definition contains all of the public-facing information that any card can contain, and it also will eventually be an abstract factory for the card runtime objects. So we'll start with a GUID for ID, and then obviously it has a name. Every card has a name. Every card has a color, but we haven't defined that object yet. Every card definition has card type. We haven't defined that guy either. I can't type. My fingers are kind of sticky from all the beef jerky. We have a subtype, which is just a string. That's because there's so many different subtypes in Magic that we're just going to make that a string. We have a casting cost to cast this particular card. We have a flavor, text. This is just other stuff that artist. And set. And then eventually we'll have something like iCard runtime, create card runtime, and then runtime. Eventually we'll have a method like that, but we haven't dealt with the runtime yet. We're just dealing with the environment pregame stuff.
And that's where the effects of the cards will be dealt with, yeah?
Yes, because in iCard definition, there's only going to be one card definition per different card in the existence of Magic. Mm-hmm. But the card runtime object is going to be instantiated per physical card on the game board once the game is started. So that's where effects and stuff are going to be played out. All right, so now we need to define some value objects. And one of them is going to be a color, which is just going to go ahead and be an enumeration to be boring. We have green, blue, white, red, black, and colorless. And then let's bring in that namespace. And now we have a card type. Card type, I'm not going to fill this out all the way right now, but it's just going to be stuff like creature, land, enchantment, and so on. Then we have casting cost, and casting cost is going to be a bit more complicated because we're going to be using this class in a lot of different areas. We're going to be using this class. We're going to be using this class to compare with, to see if a particular amount of mana in your mana pool is possible to execute with this casting cost, and so on. So it's actually going to be a more complicated class. There's two ways that we can access the casting cost of data. So the first thing is, just to make things really straightforward, we're going to have a property per color, and that's just for ease of access.
It's far easier to say that something just ignore something than it is to have to change what's there on a case-by-case basis.
All right. So then I brought in this, which decided to freeze, I think, actually. Yeah, it's not responding. Go, Visual Studio.
You want me to hit pause for a minute?
Yeah.
Yeah. All right, here we go. We'll be right back, guys. All right, we're back, ladies and gentlemen.
All right, so we are back, and we apparently have had to restart Visual Studio because it actually imploded in on itself.
Love your background.
Very nice desktop.
Yeah, very.
Yeah, me too.
Is there more of that desktop at all?
Yeah, it's chopped off.
Yeah.
And you know I have 6 screens, right? But anyway, so yeah, I was in the process of breaking this out. Okay, so casting cost. To instantiate it, we'll just have all these integers, but instead of having to add a bunch of zeros whenever we want to give like a blue cost or green cost or white cost, I want to actually make use of C#4's default property and default arguments and name arguments. So what I'm going to do is first I'm going to remove the cost from everything. And you'll see why in a second. And then I'm going to go ahead and give them all a default value of 0.
Well, this brings up a question for me.
Well, hold on. I just want to point out how you use this now, because it's actually really invalid. I think Visual Studio is just being dumb. Yeah, that's Visual Studio being dumb. It thinks there's an error when there's not. It happens. See, you went away. Anyway,
not default to 0.
So yeah. Watch this. Let's say I want to make a casting cost of 2 colorless and 1 blue. I can say new casting cost blue 1, colorless 2.
Can I ask you a quick question, Nelson?
Yeah.
Is this going to take into account, I guess it looks like it can't take into account, the situation where if you wanted to implement, was it the Unhinged set where they actually applied 1/2 mana? I'm
just
checking. I just wanted to ask.
It's a good question.
Yeah,
they would be floats.
None of the engine's going to probably support the unhinged. I don't think I'm going to have a question that the engine can ask for what artist do you want this card to be,
Sure.
or anything like that.
Are you going to be implementing IGPay at inlay?
Yeah, or the one that lets you sneak the card on the table.
Yep.
Yeah.
Cheaty face. So that's it's just really straightforward, and I am using default arguments.
Is that what I was going to ask? Is it not possible to give that signature to it if you don't define them as equaling 0? Because I thought if it's an integer, it's 0 by default.
But see, the thing is, we don't have to pass that in. See, if I were to remove this 0 from blue and green,
Yeah.
this will throw an error because it needs both blue and green. There's no default. So this is invalid.
So it's expecting that argument to be passed in.
Right. See, it needs blue and it needs green. So by providing a default, I no longer have to specify green. And
I thought integers defaulted to 0 was all.
They do, but when it's in the signature of a method, that'll actually not be possible to
okay.
Yeah.
without every argument in. And then, but that in addition with the named arguments makes things really clear. I do want to point out that ReSharper will try to make you remove argument name specification if you specify blue. That's because you can mix ordered and named arguments. So this one will go to blue, and then this colorless will go to colorless. The problem is, I personally think that's ugly. So if you ever run into an issue with ReSharper telling you to do something you think is dumb, go ahead and open up this menu and go to inspection options, and then turn it from like a warning, which shows up, like that, and it's ugly, to just a hint or do not show. So it's a lot less ugly. So yeah, so that's how we're going to be using this. So like cost 2 equals new casting cost, green 5, blue 2. So it's just a really straightforward structure. Finally, there's one thing about this method that I don't particularly like, and that's to actually, if you ever want to find out someone's color programmatically, like you don't know the color that you want to find out, and it's during runtime, I want there to be a way for you to get a color based off of an enumeration. Does that make sense?
Mm-hmm.
Mm-hmm.
So what I'm going to do is I'm going to go ahead and create a little public read-only dictionary, which doesn't exist yet. Color and colors get private set. And the read-only dictionary hasn't been implemented yet. He's going into base. So I can go ahead and just throw that abstract interface read-only dictionary. Read-only dictionary is going to be pretty straightforward. You know what a dictionary is, right?
Yeah.
Okay, so read-only dictionary is just going to be a dictionary that you can't read, or you can't write to. So he's going to be T key, T value for our generic arguments. T key, T value. So he's just going to implement INumerable of key value pair T key, T value. This opens up some neat link stuff. I don't want to inherit or implement iDictionary, because iDictionary actually has methods for things like add and remove and clear. And while I'm not forced to implement those methods in my own read-only dictionary. The fact that they're there just seems really ugly to me. So instead, what I'm going to do is I'm just going to go ahead and implement the methods and properties of dictionary that are read-only. So it's not exactly a dictionary. It's just looks like a dictionary and is only there. And I'll worry about the definition about that later. But as far as the casting cost, now we can bring that in, reference cardgame.base and use read-only dictionary. And then I'm not going to actually create the implementation, so we'll worry about set colors to new read-only dictionary. And we'll do that later. Okay, so now we have casting cost done. Our card definition is complete. So if we look back at our card game environment, we can now bring in the using for iCard definition.
Good.
So now we can go ahead and implement our iCard collection, which, like it sounds like, it's literally just going to be a collection of cards with an ID, because collections are uniquely identified with a GUID. So there's our collection. So now that's no longer red. And then finally our iDeck, which is going to be pretty straightforward. It's just going to be, just like the collections, it's going to have a GUID ID, but that's going to have something else. It's going to have an IEnumerable of iDeck card definition. And this will make sense once you see the implementation of iDeck card definition. I'm going to go ahead and implement this now. iDeck card definition is just like a shim between decks and card definitions, because it also adds the property of count. So you can have you have one iDeck card definition per individual card in your deck, or per unique card in your deck, and then you just have an iDeck card definition with the amount that you have of that card.
Mm-hmm. Did you want to go ahead and give the decks name property?
Yes, that was the final property is going to be deck details. And I decided to throw this in its own little value object because it is subject to change. Not only that, it's also subject to serialization and deserialization. And by putting it in a value object, it makes things a lot easier to change in the future.
Do you just want to clarify that serialization and deserialization?
It's going to be subject to the automatic saving and loading from a other resource. So, for example, with JSON deserialization and serialization, we're going to be taking this deck details and turning it into a JSON object, and then taking that JSON object and turning it back into a deck details.
Right.
By having the deck details, which again are subject to change, I might add like a date time created or a string author or something like that. By having this in a value type, whenever it's serialized or deserialized, those new properties will just show up. I won't have to add any additional code. If, for example, in my deck, I had string name, string description, and then later added string author, I would have to go in my code and say, okay, now save deck.author. But with this case, I can just say, go ahead and save deck details, and that will include everything that I have or might have in the future.
Right.
And then finally, I'm going to have two constructors, one parameterless and one non-parameterless. Again, the reason I have to have these constructors is because this is a immutable type. There's no way to change name or description once this object is instantiated. So obviously, I need a constructor with the name and description, but I also need a argumentless constructor. Because most serialization code, most deserialization code, the first step it'll do is it'll instantiate a new deck details, and that will require a default constructor. And then the deserialization code will use reflection to go behind my back and set these properties for me. But at that point, I don't care. So yeah, so then let's bring in value objects. And that's almost it. Finally, there's two kind of objects that need to be, or three kind of objects that need to be defined. And these have to do with how iCard collections and iCard decks come into play or get loaded into the environment. Because I don't want to restrict the environment to be only loading from one particular means. Not only that, I don't want the implementation of iCard game environment.
You okay, Nelson?
Yeah, I'm fine.
Just checking on you.
I don't want the implementation of the iCard game environment to have any saving or any loading code in it, because where that data is saved and loaded and how it's saved and loaded is going to be it's going to change in the future. And not only that, it completely defeats SRP. So what I'm going to do instead is we're going to define a little or virtually only internal use, maybe sometimes all the time, interface, two interfaces. One is called iCard or iCard Collection Factory, and then iDeck Factory. And these are going to be objects that are responsible for other code within this project to grab data from whatever source it uses, for example, a JSON file or a network stream, make invocations into these factory objects, and then spit out a properly constructed collection or a properly constructed deck. So that will make more sense once we implement these two methods, the load deck from JSON file and load collection from JSON file. It'll become a lot more clear why I chose to write it this way. Originally,
Hold up. What hotkey did you just use that brought up a menu?
Control comma.
Right. Thank you.
It's a nice one. But yeah, originally I didn't have these factories because I thought they were kind of useless. But then as I started writing the saving and loading code, I realized, I don't want to repeat all this functionality when I want to save to a network stream. And I definitely don't want this code that saves to a network stream to exist within my collection factory or my game factory or my game environment. So instead I have this little sub API that I use, which is pretty straightforward. A set ID, add card provider, which we haven't implemented yet. Talk about what this is in a second. And then it returns an iCard collection. Create card collection. Once you've configurized it properly.
Ouch. Configurized.
Yes, I do know that word doesn't exist.
Good.
Okay. I mean, yeah, I'm not that bad. So our iDeck factory is going to be pretty much the same. It's going to have set ID, set details. Again, this is also why I wanted the deck details. I didn't want a set name, set description, whatever. So instead I have a set details, which just takes in a deck details. And then an add card method, which takes in the collection ID that card appears in. Then the actual card ID within that collection, and then a count of 1 by default, and then an iDeck, create deck, and yeah. So as far as the card collection factory, what you're actually going to be sending into this factory is the actual .NET type that this card collection, or the provider. Remember, we talked about providers, I hope.
I think it was a while
back.
back.
Talk about providers, though, yes.
Yeah.
Okay.
Because we were going to have different providers.
Right. So to add a provider, you give it a type, and then you give it a read-only dictionary of arguments, which are arbitrary. Because each provider may have its own arguments that it needs, like, for example, a path to, like, if it's, for example, the Boo script provider is going to need a path to where those scripts are located, or a .NET assembly provider is going to need a path to where the assembly is located, and so on. Or a network provider is going to need like another sort of piece of configuration, like a socket or something, which can't be serialized into a string, but we'll deal with that later.
Right.
Okay.
So yeah, those are our interfaces and our value objects. At this point, all that's left is implementation.
Okay, fantastic. Well, this will be a perfect spot. At 33 minutes, we can go ahead and bring episode 14 to a close, and we'll pick up with implementation in episode 15. So thank you very much, Nelson, and thank you, Gavin, for doing such an awesome job as a student. We'll
Indeed.
see you guys
Thank you.
in the next video.